It is a pleasure to introduce Robin Tone from Albany International. We're seeing more and more and more, customers of ours, plants out there that are using these different technologies together, ultrasound infrared, ultrasound vibration, vibration infrared, as part of their overall condition monitoring programs. So I think Robin's going to share with us some of the things they've done in the paper industry. So thanks for being here, Robin.
There it goes. There. I think I got it now.
All right, thank you.
Hopefully my voice doesn't boom too bad. Great speech that we just had. I'm with Albany International. We're a supplier to the paper industry. And I also am an NFL team owner. I own one share of Green Bay Packers stock. So, four areas that we're going to look at today are steam traps, bearings, steam coils, and motors. I work in the dryer sections of the paper machine, so work with a lot of steam, but also work in some other areas of the paper machines as well. One of the problems we got in the paper industry, they call it a dying industry because, with computers, laptops, everything, notebooks, stuff like that, we're just not as useful as before. Probably the printing and writing, newsprint might be dying, packaging and tissue are picking up, so at least we do have some areas of improvement. One of the things I'm going to take a look at today are first the components of a paper making machine. As probably most people don't know that. So this is the forming section. The stock will come in at 99% water, 1% fiber, and we use vacuum and gravity elements to remove the water before it goes on to the pressing section. It leaves about 26% fiber when it leaves the forming area. The press area uses mechanical squeezing to squeeze the water out. We do have some vacuum elements that take the water out of the press fabrics. Those are made out of nylon to absorb the water and then remove it into the vacuum elements. Leaves about 40% out of this area of fiber. Then we have the dryer section, which are steam-filled dryer cylinders, and then the paper is just passed up and over, down and around through that section. And it uses mass transfer and heat transfer to dry the paper from that point. Finally, we're about 95% fiber. Some paper does go about 10%. Moisture, so it's anywhere from 85, 95, somewhere in that area, depending on what type of paper we're making. We got several areas that for ultrasound and infrared in the paper industry. Since we're using steam to dry, you're getting a lot of heat transfer and stuff. So if we got profile issues, those will show up with infrared real easily, which is what I've used for most of the years. This one here, I was measuring the air coming into the dryer section, and one of the PV supply fans were showing low. Well, as it turned out, using both the ultrasound and the infrared, found a steam trap that wasn't cycling, and the other steam trap was cycling very well in the coils next to it. So actually using the ultrasound, I found where the blockage was in the steam coming into that coil, which ended up, we weren't getting the heat transfer to the air to evacuate the pockets, which halted the mass transfer, which means then you're drying harder. So you're either having to slow the machine down, or you're going to have to raise your steam pressure in your dryer cylinder. So either way, it's not effective, cost effective. So, but we found that, got rid of the blockage, got the steam back into the coils, and was able to get the heat back up. This one was interesting. Normally in the past, we've just looked at the rolls, seen what we had for smoothness. If it was under a certain smoothness, then the roll was good. But now using the ultrasound technology as well as the infrared, we can actually try to see if we got a bearing that's dragging or something. And it doesn't take a lot of drag to wear polyester out, so which is what the forming fabrics are made out of. So this one was actually the fabrics were wearing at such a rate that on the inside of the fabric, which is this side right here, and we found 2 rolls that were dragging on that. One of them I could have found probably with the infrared, but the other one I couldn't have. So good thing I had the ultrasound to work with that as well. This was about $75,000 in extra costs. This is just in the fabric. This isn't counting the extra downtime too, which can be anywhere from $5,000 to $10,000 per hour. And normally a fabric takes about an hour and a half to 2 hours to change. So, you know, when you start doing that 2 or 3 extra times a year, it starts adding up in costs there as well. Steam coils that we use in the PV systems, this I was using ultrasound for, or infrared for quite a while. But thanks to having the ultrasound, like this one here, you couldn't see anything coming out. All you could see was the blue there. Now I can use the ultrasound, listen in, and I can hear it, the steam coming out of the steam coil. So I can tell that, okay, that is where the leak's at. Maybe not pinpoint it, but at least I can get them into the right direction. This one you could see that the steam leak was right there, but it is kind of nice having the backup there as well. This one you see a lot of dark on there, but using the ultrasound I could listen in. There was no steam leaks whatsoever, but just a lot of debris on the coils, which is going to start limiting your airflow and start reducing that, so you're not evacuating the pockets as well in the dryer section. This one's a good coil right here. This is just a brace that's coming across is all you're seeing there. So this one was interesting. This is also a fan. This one here had a good fan, well-balanced fan. This one, the fan was very unbalanced. But I could see heat build up here. And as you can see with the time series plot, quite a bit different over this. But both fans were running the same speed and the same size, same motors, so on and so forth, and same belts. So what it ended up being is the one fan was built up with so much debris from the paper machine because of just stuff in the coming through the economizer, no filters, so it was building up on the fan, causing an imbalance, thus causing more heat and causing a lot of vibration, which is going to start to reduce that motor's life by quite a bit. This one was good because with infrared, I would have never noticed this at all. Temperatures were pretty cool. But I did hear something in this gearbox right here. This one was right next to it on the same line shaft, nice clean. This one, they actually tore open that gearbox and did find the problem, so we got it down before it became an issue. Another mill, I seen something similar. I told them, you know, you might want to get this shut down pretty quick, get everything fixed in there. They waited about 2 weeks, but that was maybe a week too long. All of a sudden the gearbox just blew right apart. Fortunately, nobody was nearby it. Tore everything right out of the foundation and everything. So there, maybe they should have got down a little bit quicker than what they did. So this one, actually a guy was in Dean's class here, and him and I, just the week before he took the class, we were going through a paper mill, looking through bearings and stuff. Listen to this one, no heat, didn't really sound bad. About every minute you could hear a little, like a cage rattle noise, and that was about it. 3 hours later, the whole thing just tore right apart, and when they pulled off the front cap on this is on a forming fabric, which is around $100,000 for the fabric. They pulled that cap off, oil sprayed all over the place, and on polyester it melts pretty quick. So, and you can't afford to have holes on, especially that paper, because it's lightweight coated, which is most of your magazine stock and stuff. So anyway, I just learned from that maybe I just bring it to everybody's attention right away that maybe we should take a look at that before it becomes a major issue, which this one led to about 24 hours of downtime. changing out the fabric. Then we were down to one, nothing else in inventory because they just changed that fabric 2 days before that. So this is kind of something that you need to be careful about too. Just don't always think that everything's good just because the dBs were down and the temperature was down. But if you hear something funny, probably just record it and make sure that somebody's aware of it. Now, if they decide not to shut down, then that's their problem, not ours, I guess. So well, this was pretty quick, I guess. So any questions?
All right. Thanks, Robin.